we discuss the small world model once more. Okay. So just to repeat, what is the model? That you have a grid, so everybody is node, these are nodes, okay, and nodes have 4 neighbors. Okay. There is one parameter p. P is how many levels to be considered local. Okay. P is how many levels. So, p is equal to 1 means just this 4 are local, p is equal to 2 means this 4 and 2 hop neighbors are also local. Okay. What is q? Q is number of long links each node has. So, this means q is equal to 2. Okay. Okay. And what is R? So, probability of 2 nodes u and v. So, if I choose u, and what will be the, how will I choose v? Is proportion, it is proportional to duv to the power minus r. Okay. So, r gives us that. So, and what we said, this is okay. So, I think this part is clear. Okay. Then what? Then if r is equal to 2, if r is equal to 2, we can find a short path. That is the idea. So, you may be remembering there are 2 points, one is the structural point, how small world, and functional point, that a person with local knowledge finds the small world. Okay. So, if r is equal to 2, we can find a short path. Okay. So, now what was the idea? That idea of this proof, what is short path basically means? What is short path basically means? Yeah, it will be order of log n. So, it is polylogarithmic. In short path always means polylogarithmic. Okay. So, this was the idea. Okay. Now, what we want to do? We want to prove that this is polylogarithmic. Okay. So, this is our, and then what we thought is, let us think the distance from source to target. Say this is 32. Okay. So, 32 means 0 to 32 means it is log 32 means 5 steps. Okay. And so, what we told that this 5 steps can be traversed by traversing 6 at each time step. This is one way of thinking, that if I have to traverse in log steps, then I have to traverse 6 steps at each time. Okay. Or what was the other way to get? That I do 0, 1, 2, 4, 8, 16, 32. Okay. I hope there is no problem in this. So, that is why what we told? We defined a phase concept, okay, phase J, okay. And what is phase J? For j greater than 0, this is 2 to the power j, phase J we told is, or I should write dj, okay. This is distance from target, okay. This is distance from target. This was clear. And then what is AJ? AJ is the set of all nodes at phase J. I hope this part was clear. Okay, after much fighting, I think we at least understood this part. Okay. Okay. So, what is the next step? The next step was that what is my analysis tool? That if I am at one phase, like phase J at or j plus 1, at what time I will go to phase J. Okay. So, the point is, now I have divided the entire distance in logarithmic log n partitions. Okay. In fact, it is 1 plus log n partition, but it is order log n partitions. Okay. I have divide the entire distance, and now what I want to find, that from one distance to the next distance, if I want to traverse, what is the time taken. Okay. If that time taken is constant, then what will be the time complexity? Log n, because I have to traverse log n partitions, each partition I can traverse in constant time, then it is log n. Okay. And if that takes log n times, then traversing one partition takes log n time, then what will be the time complexity? Log n square. Okay. So, it is just multiplication. So, now I have one part is done, that I have divided into log n, the second part is traversing from one to next. Clear? Okay. Now, if I see this partition, this is n cross n. Okay. So, what is the maximum distance between a source and a destination? Source and target? No. 12 minus 2. So, max okay. So, now what happens is, when I see DUV for all, okay, so that means that will go from 1 to 2n minus 2. Okay. And that can be the maximum, it can go from 1 to 2n minus 2. Now, see that from here to here, if I go, there are how many are there with of distance 1 from this node? 2. Okay, just 2. So, I can have this and write from here, from a normal point it is 4j, but from h points it is not 4. Okay, it can be 2, it can be 3. Okay. agreed. So, that is why this is the maximum limit, okay, 4j into j to the power minus 2. So, what happens, how many, so we, so duv will be all ones, u not equal, v not equal to u, this is what you are doing, all ones, all of one distance from u plus all of 2 distance from u plus all of 3 distance from u, that is how you do. So, how many in general all of j distance from u will be how many? 4j, but if u is somewhere here or somewhere here, okay, or somewhere here, accordingly it may not have 4j, the maximum it can have is 4j, okay. That is why you can put a because I have d to the power minus 2, sorry, okay, because we are working on r is equal to 2. Okay. So, this becomes 4j inverse, and that again if you take log etc., it will becomes 4 plus 4 ln 2n minus 2, which is equal to ln 2en minus 2e, and that actually gives us 4 is there 4 ln 6n. Okay. So, this is a limit which we get. Okay. This is the upper limit. Any problem? 2en is, huh? No, 2en is e is less than 3. So, this is 5.6 minus something. So, that upper limit I have written as 6n. Okay. This is also a positive number. Okay. So, it is just a crude way of writing, but I have written so that it looks neat, nothing else. Okay. Okay. So, the next point was what? The next point is that if I am at phase j plus 1 and I want to what I want? I want to enter phase j, but I am happy if I also enter phase j minus 1. It is not that I have to go through each phase, I can skip some phase also, that will essentially fasten the, not fasten, what, yeah, accelerate the algorithm. Okay. That will actually accelerate the algorithm. Okay. So, now what I say, all these nodes are Bj. So, what is Bj? Bj is all nodes which are, so what is the distance from target to this? No, what is this target, this point? This is the jth, this what is, tell me, this is, if j plus 1, then this is 2 to the power j plus 1 and this is 2 to the power j plus 2. Okay. That is what we define. So, let us think this is j, okay. Then this is this. Okay. So, this distance is 2 to the power j. Okay. So, now tell me the least number of nodes which will be at Bj. least number of nodes which will be at Bj. What can be the least? The target node is there plus all nodes at distance 1, all nodes at distance 2, all node at distance 3 up till all nodes at distance 2 to the power j. So, how what is the least number of nodes which can be there? 1. There will be at least one node at distance 1 and one node at distance 2, one node at distance 3. Okay. Means that will be there. Okay. So, then what we have is j is equal to I is equal to 1 to 2 to the power j I. Okay. This number of nodes will be there. Because I am thinking that, see, there are 4 I. The concept was that how many nodes at distance j is 4 j. So, I am thinking there is no, so at least everything that is cornered, if everything is at corner, then also you will get at least 1. So, instead of 4 I am just taking I. No, it was 4 I. So, that can be another, what you are telling is correct, that I can have a means this is again a just this one, just this one is again a limit, that is sure, but even I am extending it a little and telling that instead of 4 I's at least I will be present, that also holds. Okay. So, instead of just a single one at distance I, because if I have at one at distance 1, that will produce 2 at distance. So, if I have 1 at distance 1, that will produce 2 at distance 2, that is sure. Okay. So, I. So, this is equal to, then what is this equal to? 1 plus summation I is equal to 1 to I 2 to the power j equal to 1 plus 2 to the power j 2 to the power j plus 1 by 2. Okay. So, that is at least 2 to the power. See, this is, what is this, 2 to the power 2 j minus 1 plus 2 to the power j minus 1 plus 1. Okay. 2 to the power 2 j minus 1, 2 to the power j minus 1 plus 1. Okay. 2 to the 2, that is greater than 2 to the power 2 j minus 1. Okay. 2 to the power j into 2 to the power j is 2 to the power 2 j by 2, 2 to the power 2 j minus 1, this gives 2 to the power j minus 1 and plus 1, and that is greater than 2 to the power j. So, I write B j okay. This is the lower bound, B j is at least this. Okay. So, remember this result, B j is at least 2 to the power j. Okay. Can I proceed? Okay. Now, tell me, I have a node here. Okay. What is the maximum distance from here to any point here? a maximum distance from here to any point here. Huh? 2 to the power j plus 1? Huh? Yeah, very good. So, the maximum distance is from some point here to some point here. So, what is the distance? This distance. The distance is max distance is 2 to the, this part is 2 to the power j plus 1 and this part is 2 to the power j. Okay. So, 2 to the power j plus 1 plus 2 to the power j. Okay. So, that also you can say this is the max distance. The max distance is bound by 2 to the power j plus 2. Okay. Okay. So, now tell me, you know Bj, you know the max distance. So, tell me the probability of having long link in Bj. I have told you how many Bj's are there and I have told you the max distance. Okay. Now, tell me the probability of having links. Okay. I should tell you one more thing. I told you one more thing, but here what we calculated, what is this? Dim summation dim uv minus 2 and what is PR uv according to this? This is PR uv if you remember. Okay. So, let us calculate PR uv here. PR uv is duv minus 2 by 4 ln 6n or it is 1 by 4 ln 6n duv square. Okay. So, you know PR uv also. So, you are given max distance, you are given Bj, okay, and you are given PR uv. What is PR uv? I write it for your sake once more, 4 ln 6n duv square entire minus 1. So, now tell me what is the probability that there will be a long link from this point to this point. You can always tell a upper bound. Okay. What is the probability that there will be a long link from one point here to one point here? You can set a lower bound, that this is at least the probability. Very good. So, the mean prob u v belonging to Bj, okay, will be 4 ln 6n into 2 to the power j plus 2. Agreed? Instead of duv square, okay, very good, square. So, okay, 2j plus 4, okay, or I just write it 4 ln 6n into 2j plus 4 minus, okay, agreed? Okay. So, now tell me the total probability. Tell me the total probability.
We can submit for all the nodes.
So, into this, because this is the least number of nodes you have. So, it will be, so dot prob,
All points in BJ won't generate this max bar.
yeah. So, it is the lower limit I am telling, no. So, all the other distance are smaller than this. So, the probability is higher. So, I am just having that this is the least probability which you will get surely. Okay. So, that will be 2 to the power, this least number is 2 to the power 2 j minus 1. So, 2 to the power 2 j minus 1 by this number, 4 ln 6 n into 2 to the power 2 j plus 4. Okay. So, now since you have the probability, what will you calculate? What will you try to calculate now? Yeah. So, average means so this is the probability. So, this is the probability that there is a long link, that from this point you will reach this point. Okay. So, now the point is that you want to find out what x j. What is x j? Denote the number of time spent in a phase. Okay. It denotes how long will it spend the time in a phase, in the phase? How long a message will spend time in a phase? As long as it does not get the long link, as long as it does not get the long link. Okay. So, expectation of x j, if I write expectation of x j will be that summation of P r, okay, x j greater than I is equal to 0 to infinity. So, x j greater than I, when it will be for the all last I is equal to 1 to infinity. Yeah. So, for all the previous steps, okay, greater than equal to I means for all the previous steps it has not received any long link. If it is greater than equal to I means what? That all the previous steps it has not received long links. Okay. Only in the ith step it is receiving the long link. Okay. So, then what happens? This becomes, so what do I write? No, so this is actually giving x j, means the number of time you are staying for 1, number of time you are staying for 2, the probability for 1, probability for 2 plus probability of 3, that summation you are doing. Okay, let us see, maybe you are correct. I have to think just this problem is that when you are on camera it is very difficult anyway. So, yeah. So, what happens is that okay, I did not do this, but this actually becomes Okay. So, okay, according to you, since you have told this, I write it like this, that summation xj xi into what is the probability 1 minus 1 by 128 ln 6 n to the power I, okay, I minus 1. Okay. Is it okay? Okay. Once more I tell that what is the probability that it will traverse at the ith step? It will traverse exactly at the ith step. The probability is that it has not traversed for the last I minus 1th step. And what is the probability that it has not traversed for the last I minus 1th step? For each of the last I minus 1th step, it did not get the long link. What is the probability of getting the long link is this much. So, this much is subtracted and go on.
Should we not have to multiply it with the probability that it has traversed in the ith step?
And that is then it is ln 6n.
Xi will become I.
Hmm. Okay.
Sir, will there be an Xi there? I don't think there will be an Xi there.
Hmm?
I don't think there will be an Xi there. It is a, it's not an expected value, it is the sum of the values, sum of the number of steps. That will give the sum of the probability. We are calculating the expected value of it.
I am calculating the expected
Xi
value.
into some probability of that Xi happening. That's what he said.
Okay. So anyway, so what happens is, so what is happening is, what is value of j? Okay, anyway, so I have to look into it, but we can show that this, let us think after sometimes, okay, but we can show that this becomes actually 128 ln 6n. Okay. Okay. This way, actually this somehow you can erase and it will become and it becomes like this, okay, and that directly reduces to this, that is not a big deal, but we have to see how this step comes to this step, just have to think a little. Okay. Okay. Anyway, means I am sorry, but these are all from paper, so it's so cryptic. It's unless somebody asks, it doesn't strike the head also. Okay, we'll see it. Okay, but let us not stop the flow. So now it is very simple that you have expectation I is equal to 128 ln 6n. Okay. So what did we get essentially? That from one phase to another phase, or the expected time you will be in one phase is, the expected time you will be in one phase is logarithmic. It is 128 ln 6n. Okay. Okay. So then things become simple, that you have 1 plus ln steps and you have 128 ln 6n at each step. So then expected time actually becomes okay. Is it okay? Okay. So
Plus ln is
Number of phases,
number of phases. So
time to go from source to destination.
so first let me do this once more. Okay. So see this, what we were doing is expectation of j is equal to summation of I is equal to 1 to infinity P r okay. This is what we wrote. So is this okay? First let us see, or it will be, because this is not x I is equal to I 1, x I equal, we have written x I greater than I. So this whole, this P r is not coming us to 1. Okay. So I write it in a little different way. Okay. So what is this? Again check this. So this is basically summation of I is equal to 1 to infinity P r x I equal to 1 plus P r x I equal to 2, this way goes on, okay, P r alpha or k. Okay. From the next step what we get, see this term, from the next step what we get, P r xi is equal to 2 plus PR xi is equal to k. Okay. I am not taking PR equal to I am taking PR greater than equal to 1. Okay. So, these two are different. Now see PR xi equal to 3 will come 3 times. Huh? No, let that be infinity, but the point which Priyesh wanted to say that this is actually coming once, this is coming 2 times, this is coming 3 times, this is coming k times. So, it is basically giving the expectation. So, you have summation of I is equal to 1 to infinity PR xi greater than equal to 1 is expectation. Okay. So, now are we convinced? Okay. Okay. Thank you for the lead. So, what happens is, so now it will be simply that term, because this is PR I is equal to 1 to infinity 1 minus 1 by 128 ln 6 I minus 1, then it can be either anything. Up till here at least it should be not that, after that it can have a long link, it may not have a long link. So, nothing else will be multiplied, means after that it is do not care. For the I minus 1th step you should not have the long link, then you may have a long link. If you have a long link you stop immediately, if you do not have a long link you go on. Okay. So, this is clear. So, then this becomes as 128 ln 6. Okay. It is simple, huh? So, what are we getting now? That at a phase, at a single phase, what is the expectation time of staying in a single phase? Is logarithmic. So, our expectation time is actually okay. When is this important? When is this important? When j's, what should be j's value for this to be important? What can be highest value of j? J is max j is log n. Okay. Now, tell me, when will we not take, when will we take, when j is equal to 0 or j is equal to 1, how many steps will we take? No, we will take 1, at most 1, that will be less than 128, means we need not care about ln step, because here the number of paths or the distance is less than log n. The distance, so how long will the distance be less than log n, for what value of j? Log n. As long as j is log n, if j is log n, then what happens? What is the distance dj? It will be 2 to the power log n, 2 to the power log n plus 1. Okay. So, it is this is log n dj and this is what 2 log n. So, this distance is basically log n distance. When j is equal to log n, this distance means means the width is basically log n. The width is log n. Beyond that, anyway without long link also you can traverse. Beyond this, without long link, just within short link you can traverse, because the width is not log n. If the width is log n, or if the width crosses log n, then only you have problems, otherwise you do not have problem. So, this analysis basically needed for this part. For the other part, we can say anyway it is less than log n. For the other part, anyway it is less than log n. So, the entire traversal now takes basically 1 plus log n into 128 ln 6. Okay, and this is basically alpha 2 log n square. So, this is in fact a fantastic result. Means if you think it is so, even for calculating we were stumbling so much, but just thinking that this type of result can exist is, yeah, that is why it got published in Nature. Okay. So, idea is clear. Okay. So, now we go on for, I do not think we will get full time, but not to, but from 0 to 2 what was the what is the result? N 2 minus R by 3. So, when R is between 0 to 2, it is polynomial, again from 2 onwards it is again polynomial, only for 2 it is logarithmic. Okay. Okay. So, for 0 to 2 let us see. Okay. I will go on fast for this. The base, I hope now the basic theorem is very clear to you. Okay. So, now I am putting a greater than sign. So, this is greater than, means at least what we know, the maximum distance will be, the maximum distance is 2n. So, at least it will be n. Okay. So, if I take n by 2, that is we are not considering it, and we are not considering 4j, we are considering just j. Okay. So, this term is always greater than this term. Okay. And from there, actually with some calculation, okay, we get this term. Okay. Now, we can put okay, and now let us think you have a target, and U is a set of nodes which are at distance okay. So, again what will be U? 1 plus j is equal to, U will be less than the upper limit, I am just trying to find the upper limit of u is okay, this is the upper limit of u. Now, I again try to find out that, so there will be, so let us write dash is an event okay, just listen to this term, then is an event that reaches a node other than t in the long range contact of u. Okay. Through a long range, it's the same concept like the previous, a node that reaches this is an event which tells that a long range node, long range contact reaches at u. A long range contact reaches at u. Okay. Huh? U is this set, the set of nodes here, and that is that. And so, epsilon, so what we see is PR epsilon is less than 1/4. Okay. PR epsilon is less than 1/4. There is a long range contact. Okay. The next point is that if I think that two nodes, what is the distance between them? If I pick up two random nodes, what is the distance between them? Okay. And it can be shown that PR F is that distance is greater than 1 n by 4. Okay. Distance is greater than 1 by 4 is greater than equal to half. Okay. You can think that there are actually, what are the distance, probable distance from 1 to n minus 2n minus 2, but as you go higher the number of nodes increases. So, up till n by 4 it is just 1/4. Okay. And so, what we say PR, if this is that they are at that distance and there is no long link used. Okay. They are at that distance and there is no long link used, that is greater than 1 by 4. Now, what you say that if I am at n by 4 distance, okay, if I am at greater than n by 4 distance and I want to reach in lambda n steps. Okay. Well, lambda is a arbitrary constant. Okay, it is not an arbitrary constant, but we need not worry about lambda. In lambda n by square. So, this distance is greater than n by 4 and says gamma is an event that I reach target in n by 1 steps. I reach target in n by 1 steps. Okay. So, now it can be shown that if you have to reach this target, okay, if you have to reach this target, then you have to have a long link. Okay. If you have to reach this target within this time step, you have to have a long link. Okay. So, now I write expectation of x, that at means at what steps you will reach. So, this is expectation of x given f plus expectation of x given f bar. Agreed? I can write this. So, this is half this is at least greater than half of expectation of x given f bar. Okay, I did not, this is greater than expectation of x given f, okay, and this is expectation of x given f intersection okay, agreed, and this is actually greater than expectation of x given okay. Now what we told that expect if f bar, if this bar, okay, if this does not exist, then what, you cannot reach within these steps. Okay. So, let us write this a little better way. This is expectation of x into p f given sigma bar. And what is expectation of x in this case? What is expectation of x in this case? It is always greater than this, because what you are telling, if this event occurs, then you cannot reach within these time steps. So, this becomes, and this you can write, and you will see this becomes, what did we write? This becomes basically you can go into the detail, I will upload the paper in the web page. So, this is how, again, if r is greater than 2, similar analysis helps us. Okay. Thank you. So, tomorrow is last class.